Hello, everybody. So today we're going to be starting into Chapter 6, Section 2. And this is a continuation of the last section that we did, where we learned about systems of linear equations and how the information about the slope and the y-intercept can tell us how many solutions that system might have. And hopefully you recall that there are three different possibilities when you graph two lines as to how many solutions there could be. There could be one, which means the slopes are different and the y-intercepts are different, and they cross in the same cross in one place. The y-intercepts could be the same for that too, but the important part is the slopes are different. There's also the scenario where the slopes and the y-intercepts are the same, in which case they're the same line and they share all their points, so there's an infinite number of solutions. And then there's the third case where the slopes are the same, but the y-intercepts are different, which would give you two parallel lines, and therefore they would not intersect, which means they would not have any solutions. So today I'm going to show you how to solve these algebraically, meaning using algebra. And the way that we do that is we use a method called substitution, which I will show you here in a second. So real quick review, there are three types of systems that we talked about in the first section: independent, dependent, and inconsistent. So independent systems have one solution, dependent systems have an infinite number of solutions, and inconsistent systems have no solutions. So there are three different methods to solving these systems. I briefly touched on solving these by graphing last time. I kind of really just showed you how to graph the two equations. I didn't talk about actually finding the point, but that is one of the ways to solve a system. There's also substitution, which is using algebra, and then there's also elimination. So I'm going to show you how to solve systems by substitution. So what we have here is we have two different systems. One is in slope-intercept form. You can see the first one is y equals 2x plus 1. It lines up very nicely with y equals mx plus b. And then the second one is in standard form, which is ax plus by equals c. So what we do in the case of having one in slope-intercept form and one in standard form, it is extremely helpful to have one of the equations in slope-intercept form, because we need to know what one of the variables are by themselves. Okay. Now, in this case, we know what y is. Y is 2x plus 1. So what that allows us to do is it allows us to, in the other equation, substitute the 2x plus 1 in for y. And the reason why we can do that is because the first equation tells us that y is equivalent to 2x plus 1. So in this second equation, I'm going to take the 3x, I'm going to leave that alone, but in place of the y, I'm going to write 2x plus 1, and then I'm going to still leave it as equals negative 9, like that. Now, the reason why we do this is we now have one single equation that has only one variable. There are not two different variables. There's one variable that is the same. There are just x's. And if you remember that whenever you have variables that are the same, they can be combined because they are like terms. So that's really important to eliminate one of the variables by substituting in one equation into the other, which is what we did. So we're going to add up those two things that you see I underlined there. 3x plus 2x becomes 5x. Then we have plus 1 and then equals negative 9. So we added the two like terms, the 1 dropped and the negative 9 dropped. And so now what you see is a two-step equation that you guys have solved a whole bunch of those already. So we're going to subtract 1 from both sides, and we'll get 5x is equal to negative 10. And then I'm going to divide both sides by 5, and I get x equals negative 2. So there you go. We have an answer. Now, the thing is, though, if we go back up here to look at our original equations, and I'm going to erase this so we can look at both of those equations have a y and an x in them. And so a solution to the system is actually an ordered pair, x, y. So we have found what the x is. We found that x is negative 2. We now need to figure out what y is. The way that we're going to do that is we're going to substitute the -2 in for x right in there in that equation, because that one is already solved for y. So if I write the equation y equals 2x plus 1, and then I'm going to substitute in -2 in for x. And we get -4 plus 1, which gives me y equals -3. So there's the other number we need, which we now then can finish the ordered pair. And you can see that the ordered pair is -2, -3. Now, what does that mean? Well, if we were to graph both of those equations on a coordinate plane, you would see that these two lines would cross at that point, -2, -3. Therefore, there is one solution. So we're going to do the same exact thing as we did in the last example one. You have something in slope-intercept form, and then you have something in standard form. You can see that 4x minus 6 is equal to y. So I'm going to put that right there in for y. So I'm going to rewrite this 5x plus 3 times 4x minus 6 equals -1. So I just substituted in place of the y for x minus 6. You must put parentheses in there. I can't stress that enough, because this 3 here needs to distribute to both things. So the 5x comes down, and then I'm left with 12x minus 18 equals -1. And 5x and 12x becomes 17x, because these two are like terms. They're going to add up. And then we have minus 18 equals -1. I'm going to add 18 to both sides. 17x equals 17. And then I'm going to divide both sides by 17. And I get x equals 1. So there's one of the two numbers we need. Remember, we also need a y value. We're going to get that y value by substituting this x back into that equation right there. So I'm going to write that equation y equals 4x minus 6. In place of the x, I'm going to put a 1. And I get y equals -2. So there's my other number. Once you get your x and y, you have to write the ordered pair. So in this case, the x was 1 and the y was -2. So we write the ordered pair 1, -2. And once again, because we ended up with one ordered pair, that means if you graphed both of these lines, they would intersect in one place. And that's the point where they would intersect. So the last one we're going to do today is a little bit different than the first two. And the reason why it's different is this particular system does not have an equation in slope-intercept form. There is not one solved for a single variable. So your goal or your job here now first is going to be to get one of the variables by itself. Now, as a hint, it doesn't matter which variable you try to solve for. You can solve for this x or this y. You could solve for this x or this y. But typically, there is an easiest one to solve for. In this case, if you ever have a variable by itself with no number, that's always going to be your best bet to solve for it. So we're going to use this first equation, and we're going to solve for x in this equation. The way that I'm going to do that is I'm going to move the 2y to the other side. And what I end up with is x equals 6 minus 2y. Okay, so since we now solve for x, what we're going to do is we're going to take this stuff that we solve for x. We know that equals x. Well, x is right here. So I'm going to take what I solve for x and I'm going to plug it into the other equation in for x right there. And so when I do that, I get a new equation, 3. Now in place of that x, I'm going to write 6 minus 2y. And then the 4y comes down, and then the 28 is still there. So I substituted in 6 minus 2y for x. Now remember, you have to substitute that into the other equation that you didn't use. We use this first equation right here to come up with this. So then you have to substitute what you get into the other equation. Now this 3 needs to be substituted. So 3 times 6 is 18. And then 3 times negative 2y is negative 6y. And we have minus 4y, and that equals 28. Okay. From there, I see that I have two like terms right here. So those two are going to get put together. Negative 6 and negative 4 is negative 10y. And then it becomes 28. I'm going to subtract 18 from both sides. I'm going to proceed to solve this. So I get negative 10y equals 10. And then I'm going to divide by negative 10 on both sides. And when I do that, I get y equals negative 1. So there's one of the two numbers I need. Now remember, you're getting an ordered pair. That ordered pair is x, y. So we've got the y, now we need to get the x. Now the question becomes, where do I substitute that x back into? Where do I substitute that y back into? Because we don't have, we might not know. All the other ones we've substituted the x in. Well, here's what you do. This y can be substituted in any of the equations. It could be put in this one, it could be put in this one, or it could be put in this one. It doesn't matter. Any of the three equations are fine. Now, what I would suggest, though, is since we're trying to find what x is, and this equation is already solved for x, this y is going to be the best equation to substitute it back into. So I'm going to take this negative 1. It's going to get put right in there. So x equals 6 minus 2 times negative 1. You can see the y was replaced with the negative 1. Then I have x equals 6 plus 2, because negative 2 times negative 1 is positive 2. And then I get x equals 8. And I get my answer. So there's my second answer. Remember to write your ordered pair. Remember, the ordered pairs are always x and then y. So it has to be 8 and then negative 1. And so again, as the last two examples, there is one ordered pair, and that ordered pair is going to be where those two lines would cross if you had graphed them in the coordinate plane. So there you go, guys. I hope that made sense. As always, if you have any questions, please feel free to email me. Have a great day.